I'm Pat Dugas, and this screencast is about dividing polynomials, both by monomials and polynomials, using both long and synthetic division. So let's compare division of numbers with division of polynomials. So if we have a problem like 3 divided by 107, the way we do that is we take the 3 and we kind of go step by step. Well, 3 goes into 10 3 times. So 3 times 3 is 9, so we're going to subtract 9 from the 10. That leaves us a 1. Then we bring down the 7, and we're left with 17. So 3 goes into 17 a total of 5 times. 3 times 5 is 15, so we subtract the 15 from the 17, and we get 1 minus 1 is 0, 7 minus 5 is 2. Since 3 doesn't go into 2, that becomes our remainder. In a similar way, we can divide polynomials by polynomials. Let's take the case of x squared plus 2x plus 5 divided by x plus 3. Well, we figure out how many times x plus 3 will go into this thing. So we just look at the leading term. How many times does x go into x squared? Just like over here we said, how many times does 3 go into 10? How many times does x go into x squared? Well, it goes into it x times, because x squared divided by x is x. So now that we know that, we multiply out x plus 3 times x. Well, x plus 3 times x using the distributive property is x times x, x squared, and 3 times x, which is 3x. So we're going to subtract the entirety of x squared plus 3x, just like we subtracted 9 over here. When we do that, the x squareds cancel out, and we're left with 2x minus 3x, or negative x. We bring down the 5, just like we brought down the 7 over here. So we get x plus 3 divided by negative x plus 5. Well, x plus x will go into negative x negative 1 times. X divided by negative x is negative 1. When we multiply x plus 3 times negative 1, we get negative x minus 3. And we subtract that out just like we subtracted the 15 over here. Negative x minus negative x, the negative x's cancel out. 5 minus negative 3 is 8. That's our remainder. So the answer to the problem of x squared plus 2x plus 5 divided by x plus 3 is equal to x minus 1 with a remainder of 8. Now, the way we would write the remainder of 8, we actually would write that as plus 8 divided by x plus 3. Okay, just like in the division on the left, we would write 107 divided by 3 is equal to 35 plus 1 over 3, or 35 1/3. So hopefully this helps you see the similarities between polynomial division and division of real numbers. Now, in a simpler case, if we're taking a polynomial and dividing it by just a monomial, we can actually take each of the terms one by one and divide them out. So if I have 5a squared b minus 15ab to the third plus 10a to the third b to the fourth, all divided by 5ab, I could actually use the division process that I just showed you, but another way is to just rewrite this as 3 separate terms, because after all, the 5ab is going into all of these. Now we're looking for things that can cancel out. Well, 5 divided by 5 is 1. A squared divided by a is just a, and b divided by b is b. If we continue that process, 15 divided by 5 is 3. A divided by a is 1. B to the third divided by b is b squared. 10 divided by 5 is 2. A to the third divided by a is a squared. And b to the fourth divided by b is b to the third. Now it looks kind of like a mess, but in the end, when we simplify all this, we get a minus 3b to the second plus 2a to the second b to the third, and that's our answer. If we're dividing a polynomial by a polynomial, however, we have to use that division process. So if we have something like x squared minus 2x minus 15 divided by x minus 5, we're going to use that long division process. Okay, so x minus 5, we're looking for how many times x goes into x squared. Well, it goes in x times. And so we distribute this out, the x minus 5, and we get x squared minus 5x. We're going to subtract that just like we did on the first set of slides, and we get x squared minus x squared is 0. Negative 2x minus negative 5x is positive 3x, and we bring down the negative 15. Now we're going to repeat the process. How many times does x go into 3x? It goes 3 times, positive 3 times. So we're going to distribute the x to the 3 and the negative 5 to the 3 to get 3x minus 15. We subtract that out. Now I put parentheses around what I'm subtracted to remind me to distribute the negative 1. So when we subtract that, we get 0, which means that this has no remainder. It is a perfect factor. So in the end, the answer to 2x squared minus 2x minus 15 divided by x plus 5, it's equal to x plus 3. Okay, in some cases, when we're dividing a polynomial by a binomial, a special polynomial with only 2 terms, we can use what's called synthetic division, which is a shortcut. Now, I'm not going to read through every one of these steps. We're going to actually do a couple of examples of it, but it is a slightly different process than the long division. So let's say we take x to the third minus 4x squared plus 6x minus 4 and divide it by x minus 2. So we're going to write the terms of the dividends, so the degrees of the terms are in descending order, always descending order. Also, even though my examples don't have it, if you have a power that's not represented, you need to put a 0 there. For example, if there was no 6x term here in my division, I would write a 0 for that. Just like you would put a 0 in the, say, the tens place. Okay, so dividend here becomes 1, negative 4, 6, negative 4. So we're just writing the coefficients down. And remember, if there was a term that was missing, we'd put a 0 there. Okay, then you're going to write the constant of the divisor to the left. In this case, that's 2. Okay, and it's in the form x minus r. So if it's something minus a number, then we put that number there. If it's something plus a number, we make it a negative of that number. It's whatever turns that thing in the parentheses to 0. In this case, that's the value of 2. So the next step is then to bring the first coefficient down and put it underneath this line. Okay, so once we've done that, what we do next is then to multiply this r number by whatever number's here. And we're going to repeat this process. Okay, so 2 times 1 is 2. And we're going to put that 2 directly under the negative 4, the next one. Okay, this is a shortcut. It's really doing the same thing that we do in long division, but it's a simplification with the coefficients. So 2 times 1 is 2. We put the 2 up here. Now we add, okay? And the reason we're adding is because we've kind of multiplied the whole thing by negative 1 by putting the opposite of what we think here. So negative 4 plus 2 is negative 2. And we write this number down. And now we're going to repeat the process. We're going to multiply the 2 times negative 2 and write that number here. We're going to see 2 times negative 2 is negative 4, and we're going to write the number right here. So 6 plus negative 4 is 2. We're going to repeat the process one more time. 2 times 2 is 4. Negative 4 plus 4 is 0, which means we have no remainder. So the numbers at the end represent the coefficients of each of the powers and then the remainder in your answer, which is called the quotient. So this is the x squared term, this is the x term, and this is the constant term. Okay, so our answer actually is 1x squared, or just x squared, minus 2x plus 2, and there's no remainder on this one. So that's actually our answer. Now, once you learn this process, it tends to be faster than long division. Let's look at a more complicated synthetic division problem where it's a binomial, but it's a little bit more complicated binomial. But for synthetic division to work, we want this divisor to have a leading coefficient of 1. So we got to divide everything by 2. And when we do that, we get 2y to the third minus 3y squared plus 2y minus 1/2. Okay, and then the denominator then becomes y minus 1/2. So now r equals 1/2. We're going to go ahead and write this out with our coefficients. The y to the third power. So this is the y to the third power. This is the y to the second power, y to the first power, and the constant term. So r equals 1/2. We're going to bring down the 2. Or 1/2 times 2 is 1. Negative 3 plus 1 gives us negative 2. 1/2 times negative 2 is negative 1. 2 plus negative 1 is 1. 1/2 times 1 is positive 1/2. And then 1/2 plus 1/2 is equal to 1. So our solution, this is the y squared term. This is the y term coefficient. And then this is the constant and our remainder. So our answer actually is 2y to the second power, that's this part right here, minus 2y, that part right there, plus 1 with a remainder of 1, which means it's plus 1 over y minus 1/2. Now, if we want to get rid of the 1/2, we can actually multiply the numerator and the denominator by 2, but this is a correct answer as well. So we've looked at dividing polynomials, both by monomials and polynomials. When we divided by polynomials, we have to use either long or synthetic division.